All right, let's do 7.5b. So this is the last thing we're going to do before spring break. So pause me and write all of that down. Okay, so use the conditions that are given here to find some different things. So we're going to have more than just this, but it's lower on the paper. So I'm leaving space here because we're going to actually draw a picture for both of these angles. This is called alpha and this is called beta. I'm going to use different colors for those because they're different angles. Now, these are just like theta. We're used to seeing theta, right? It's a Greek letter. We use Greek letters to represent angles. Okay, so don't be freaked out by that. It's just representing an angle. So remember, we take a trig function of an angle and we get a ratio of sides. So you need to remember that sine, the ratio of sides for sine is y over r. Oops. Y over r. And the ratio of sides for cosine is x over r. I'm sure those are well embedded in your mind. So I'm going to draw a picture for this one first, alpha. I need to think about what it means for alpha to be between 0 and pi over 2. So pause me and think about that for a second. Okay, so hopefully you came up with 0 to pi over 2 means it's in quadrant 1. Excuse the obnoxious children in the background. So I'm going to draw a picture in quadrant 1. And I'm going to have the y value is 7. Y over the r value is 25. Y over r, right? I don't know the x value, but I do know that that's a right triangle because that's how we set them up. So we need to think about how we're going to find that missing side. I know you all know how we're going to find that. We're going to use Pythagorean Theorem. This happens to be a triple. 7, 24, 25 is a triple. If you don't remember that triple, you're just going to go 25 squared equals 7 squared plus x squared. 25 squared equals 7 squared plus x squared, and you're going to solve for x. So now I have all the sides. This reference angle here, or this angle, is called alpha. I don't know the measure of that because I'm not in the unit circle, but I can reference it as alpha. I'm going to name it instead of giving it a value. And then over here, I'm going to talk about beta. Beta is a different angle in a different quadrant. It's going to have a different picture. So first, figure out what this means. It's between negative pi over 2 and 0. Okay, so that means it's in quadrant 4, right? Negative pi over 2, right? And I know the x value is 4 rad 41, and the r value is 41. I'm going to show you a little trick on this. Maybe. We'll see. It might be a little more advanced than we need to get. But so the x value I'm putting along the x-axis. The r is the radius or the hypotenuse, because remember we're picturing a circle going around that. This time we don't know the y value, and this is not a Pythagorean triple. So we need to find the y value. So the x squared plus y squared, right, equals r squared. So probably going to need a calculator for this. This is going to be 16 times 41. And then 41 squared. And then I would subtract the 656 from both sides. And then take the square root of both sides and simplify. Okay? If I'm going too fast, just pause me. Pause me when you need to. So there's that. Okay, now I have all the information I need. I have the x, y, and r for both of the triangles created. So I'm going to go ahead and calculate sine of alpha plus beta. Now here's where I really need to know the song. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. So sine is the sine, cosine, cosine, sine part of the song. And then we remember alpha, beta. We did not clap, so that plus stays the same as that plus. And then alpha, beta. Okay? So now I'm going to look up here. Oh, I already know sine of alpha. That was given. That's easy. Let me write this. I'm trying to color code this. 7 over 25. That was given. I don't even need to look at the picture, but I can confirm it with the picture. 7 over 25. Cosine of beta, that was also given. That's right here. You're like, why did we do those pictures if everything's going to be given? It's not going to be, trust me. Hey, bud, can you go in the other room, please?
Yeah.
Now. Cosine of alpha, I need the picture for. That has not been given to me. So I'm going to look at the picture. I'm going to remember that cosine is x over r, and I want to make sure I'm looking at the alpha picture. So x over r is 24 over 25. Nathan. Sine of beta also was not given to me. Okay. So I'm going to look at the picture. I want to remember that sine is y over r. So I'm going to look at the y value over the r value. And then now it's just arithmetic at this point. So again, you might need a calculator for this. Well, I bet you can do this without a calculator. I would challenge you to do this without a calculator. 25 times 4 is easy. That's 100. So 25 times 40 is 1,000, right? So 25 times 41 is just an extra 25. So it's 1,025. So I'm going to do 7 times 4 rad 41. I can multiply the 7 and 4 because they're both outside of the radical. 25 times 41 we just figured out was 1,025. 24 times 5, I'm going to do 5 times 20 is 100. Plus 5 times 4 is 20. So 120. So my final answer, I can smush these together because they have a common denominator and a like radical. And I just realized I made a tiny mistake because hopefully you guys caught this. This is a negative y value, isn't it? So that's actually a really common mistake that everybody makes. Is thinking in terms of the Pythagorean theorem, but not thinking about the fact that this is going down, so it's negative. So this should actually be negative, which means then a positive times a negative is going to become a minus, and then I need to think, sorry about that, guys, 28 minus 120. So subtracting 20 takes me to 100, and then subtracting 8 takes me to 92. So that's actually the correct answer. Okay, let's do one more of these. Actually, we should do 2 more. Let's do a cosine and a tangent. So let's do, where are we at in time? Okay. Let's do cosine of alpha plus beta. So again, we need the song. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Remember that the cosine part of the song is the part of the song that starts with the cosine. So it's cosine, cosine, clap, sine, sine. Remember the clap stands for the change in SIGN from positive to negative. And then we go alpha, beta, alpha, beta. Cosine alpha, we already figured that out up here, 24 over 25. Cosine beta was given to us. Sine alpha, we figured out, nope, that was given to us, 7 over 25. And sine beta, we figured out up here. Can't beat this education system we have right now with kids screaming about their layer in the background, right? Okay, and then we're going to just do the same thing we did before. 24 times 4, that's 80 plus 16. And then this is going to become a plus, right? 7 times 5 is 35. And then I'm going to add those together. What is that? 110 plus 11, so 121. I'm not trusting my math right now. I'm actually going to check that. 96 plus 25, that's 11. That's, yeah, 121. Okay. So hopefully we're good there. Pause that if you need to take a second. And then we're going to do a tangent. Okay, so let's do tangent of alpha minus beta. This was one that I didn't have a song for. So you kind of just have to memorize it. And then we haven't figured out tangent for any of these. So we need to figure out tangent of alpha. We're going to look at the alpha triangle and we're going to go y over x for all of these tangents. So y over x is 7 over 24. Tangent of beta, y over x. So I'm going to do the y over the x. There's a minus in between, but tangent of beta is also negative. The y value, right, over the x value. And then divided by 1 plus tangent of alpha times tangent of beta. Oh my God. Whitney, Olivia. So much fun, you guys. Seriously. Okay. The radicals cancel out. The radicals cancel out. So we end up with 7 over 24 plus, 5 over 4 divided by 1 minus, positive times negative, 35 over 16. Now, here's where we're going to use something that we learned earlier in the year. We want to get rid of all of these fractions. Ooh, that's actually not going to be pretty because 16 and 24, I don't know what the LCD of that is very easily. So I'm actually going to use a different method than what I have suggested throughout the year. I don't want to give myself the amount of work that's going to be required to figure out the LCD of, oh, actually, it's not that bad. It's 48, isn't it? I'll show you 2 ways then. The way that I figured that out was I just thought, well, 24 is the bigger number. If I multiply that by 2, I get 48. And then I realized 16 went in nicely. So that's what happened. I'll do that way in a second. The way where you don't have to figure out that LCD is to give these a common denominator. And give these a common denominator, and then smush the top together. So this is 7 over 24 plus 30 over 24 divided by 16 over 16 minus 35 over 16. Smush these together. Smush these together. What is that, negative 19? I honestly won't be surprised if I'm making mistakes here with all the screaming going on in the background. I apologize, guys. And then multiply by the reciprocal. I like to reduce my numbers before I start thinking about multiplying. 37 and 19, there's nothing going to reduce anywhere with any of those numbers. So now I'm going to multiply 37 times 2, and I'm going to multiply 3 times 19. So what I get in the habit of doing is 3 times 10 and 3 times 9, but another way of doing it is 3 times 20, and then subtracting off the excess. What is that? Negative 57, right? And I'm pretty sure that that is irreducible. So really fast, we're under 15 minutes, and that was my goal for these. So I'm going to show you the other way to do this. This is actually the way that I prefer and the way that I was planning on doing, but the denominators aren't the easiest. Usually they're easier than this. So if I can figure out the least common denominator, I'm going to multiply every single thing times that LCD. Every single thing. Okay? Basically what I'm doing is multiplying by 48 over 48 and then distributing. And then I can cancel. 48 divided by 24 is 2. 4, it goes into 48 12 times. 48 times 1, there's nothing I can do with that. And then 16 goes into 48 3 times. So now I have a much easier problem. I have 2 times 7 plus 5 times 12 over 48 minus 35 times 3. What is that? 90 plus 15, 105. And then I end up with that same fraction. 14 plus 60 is 74, and then 48 minus 105. So I personally find that way a lot easier than this way. Okay, so let me know what questions you have on this, and I hope you guys are doing well.